solve that inequality. So what I did, I factorized it and found the critical values. And I just done this rough graph. If you can see that where that a function is bigger than or equal to 0, it's after 10 or before a -4. So it's either that or that. Solve that inequality. Well, before I do anything, you have to notice that it's a upside down quadratic. It's been reflected. So I factorized it. So to make that actually equal to 0, the critical values are x equals 0 or x equals 4/3. If you can't spot that, it's 4/3. Just make 4 minus 3x equal to 0 and just solve that simple equation. You know, that bit that's inside the bracket. And it comes to 4/3. So those are the critical values. So there's my little graph again. And where is that actually greater than 0? Well, it's greater than 0 between x is 0 and x is 4/3. So so that's an and. It has to be greater than 0 and less than 4/3. The other one was at or. All right, this one I factorized it, found the critical values, just drew a little graph for myself just to get the big picture. And where is it greater than or equal to 0? See, those circles should be colored in actually. It's either greater than 2 or less than -3. Number 4 is just a bit of algebra. Expanded the brackets, took the x's to one side, and just solved that. And the first one, just simple algebra again. And part B, I factorized it and to find the critical values. And instead of drawing a graph, I just substituted a number like a 0 and into there, and saw it was it less than 0 or not. So if I put in, say, 0 into the x, I got 3 times 0, which is 0. Take away 1, so it's -1. And 0 add 3 is 3. -1 times 3 is -3, which is less than 0. So it's an and. So everything between those two critical values. Number 6, you had a room 4 meters longer than the width. So I said the width is x, so the length must be x plus 4. I worked out an expression for the perimeter, made it greater than 19.2, took away 8 and divided by 4, and that gave me x is greater than 2.8. And given that the area of the room is less than 21, so I worked out an expression for the area, made it into inequality less than 21, took that 21 over to the other side, and I factorized it, and it was less than 0. Found the critical values like before. So x was between -7 and 3, and that's that inequality. So then hence find possible range of values for x. So it had to be true for both inequalities. So I just did a very simple x-axis, a kind of section of it, for both inequalities. So one was greater than 2.8 and the other one was between -7 and 3. And the inequalities, they have to overlap. Okay, the ones that it's true for. So the overlap is between 2.8 and 3. Number 7, write that in that form, hence show that it's greater than 0 for values of x. So that is just whenever you see that, that's going to be the completing the square. So so I did that. The corners of the vertex, so that's actually 5/2 to the right and 7/4 up. So that's the minimum point. Remember, it's a quadratic, it's a positive quadratic curve, and that is your minimum, or the vertex. And since the y coordinate is positive and it's a minimum, so that means it's going to be greater than 0 for all x. Okay, so it doesn't actually cross the x-axis. And there you go, part 2. They've actually asked you to draw it. Whenever you get asked to draw like a quadratic, all right, rather than draw yourself a little table and put the x coordinates on the top and the y coordinates on the bottom, like GCSE plotting a graph, it's best to complete the square, and then you know how much left, right, up, down that you need to go. Okay. And even if you do have to sketch it without completing the square, it's just a sketch. Okay, so don't start actually working out lots of coordinates. You'll be there all day. So number 3, part 3, find the set of values for x for which that is greater than 14. So I took away 14 from both sides, ended up with that quadratic, factorized it, found the critical values, and then I said to myself, where is it greater than 0? So it's a positive x squared curve. So it's going to dip below the x-axis, but it's going to be above it on the left-hand side of -1 and on the right-hand side of 6. So if that was an or, either that or that. And part 4, does it cross the x-axis, and show how you decide. So I just wrote a few things there. The minimum y coordinate is 7/4. For y equals f of x minus 10, all right, the minimum coordinate, so the whole graph has moved down 10 units. So from being the minimum point of 7/4, you move it down 10. So the new minimum y coordinate, the x coordinate stays the same. The new y coordinate minimum is -33/4. So and that shows that it was positive before, now it's negative, so it must have crossed the x-axis. Okay.